A memorandum to J.B. White. Subject, solution to our Toppet packaging problem. I know you're very interested, J.B., in what was done about the problem. As you know, it came to light during the visit I made to that big supermarket. We were launching our new product, and that store manager knew from my interest in the display that we were expecting big things from Toppet. And as he pointed out, the package is what really sells a brand new product to a customer the first time. But then, well, you heard what happened. It had become as hard as the well-known rock. They'd had a good deal of rain, and our package just didn't hold up to all that extra moisture in the air. I guess that little experience sort of ruined the store manager's confidence in our product, because he began to tell me about some other products he was planning to drop, and why. It wasn't hard to get the message. As he put it, a store manager just isn't going to bother with products that are poorly packaged. They lose customers for him. They cost him money and spoilage and handling problems. Well, J.B., we know we have a good product here, but it might have died if we hadn't started an all-out crash program to see what could be done about that packaging. I started by checking things over with our packaging engineer, and of course he would have to remind me of our demands to cut costs, how we had put the heat on to cut packaging costs first. Well, as we know now, we didn't get away with it. Our failure to protect our product against moisture was really hurting us. But that engineer of ours is sharp, J.B. He'd had some doubt as to the protection our product would receive when we cut packaging costs, and in anticipation of this, he'd requested the Milprint representative to visit us. Frankly, that discussion was quite an eye-opener. I'm convinced the Milprint man actually represents sort of a new form of business insurance. When he looks over your packaging, he's talking not just about wrapping products, but protecting a company's sales and profits. The idea struck me so hard, I wanted to see if he could really back it up with facts. Well, he not only could, he arranged for us to go see for ourselves just what goes on at one of the Milprint plants. We didn't waste any time following up either. When we got there, the man we wanted to see was just coming out of a meeting of their technical committee. We learned that this is a group of their packaging experts, engineers, stylists, production people. It seems that these fellows apply their special knowledge of laminations to the solving of any unusual packaging problems. It looked like a lot of high-powered talent just to solve a packaging problem. That is, until I noticed some of the things they must have been discussing. Now, obviously, they don't consider a package merely a container for a product. They must have been going over such things as how the packaging could draw consumer attention, how to get product or brand identity, how better preservation of the product might level off production schedules, how packaging could help in the shipping, storage, and distribution handling of the product. We were told that the package must not only get the most consumer attention and provide the most product or brand identity, but it must also give information about the product, such as uses, benefits, instructions. There seemed to be a lot more to a package than simply eye appeal. For the job they'd been discussing when we came in, they were even considering a package that would serve as the container in which the product could be cooked. Now, in this case, it looked like the best bet was a new water-soluble material that actually dissolves when the entire package and its contents are placed in boiling water to cook. When I mentioned what a convenient new packaging idea this was, the Milprint man reminded me of a lot of other products that wouldn't even be available today if it weren't for modern packaging developments. Things like instant mashed potatoes, instant milk, refrigerated biscuits, water ice confections. They weren't all food products either. He reminded me of the moth crystals, cleansers, and even lubricants that are now distributed better with flexible packaging. And he pointed out that the development of laminated and extruded packaging materials had been the biggest factor responsible. Of course, I agreed that flexible packaging could be useful and convenient, but why all this study of laminations and extrusions? Wouldn't a good, strong foil, paper, or film be just as good in most cases, and a lot cheaper, too? Well, J.B., I guess I really walked into it with that question. You'd think I'd ask him to go back to the Cracker Barrel days, but he was very patient with me. First, he pointed out that single materials each have their own useful characteristics. The trouble is that each is limited in other characteristics that might be desired for certain packaging. So single materials are laminated using waxes or adhesive under heat and pressure to form a sort of sandwich that bonds all of their desired characteristics in one piece. That means products can be packaged with a combination of materials in just one economical run through packaging machinery. Using some label blocks to illustrate, he pointed out that the adhesives used to bond the various materials can also be selected for certain desired characteristics. And as I soon realized, the number of possible variations in combining materials and adhesives are almost limitless. In addition to many types of paper and metal foils, they're using such things as sulfite, glassine, polyethylene, mylar, saran, nylon, pliafilm. And the new wonder materials they're investigating will open up even more possibilities. The selection of the right combination of materials for a particular packaging problem is no job for an amateur. You know, as our packaging engineer pointed out, our problem was creating a moisture barrier for our product. And so from the thousands of possible combinations, the Milprint people had to select ones that would provide all the desired characteristics at the greatest economy for this particular application. They also had to keep in mind our present investment in packaging machinery. For this, they even work with packaging machine manufacturers with suggestions that provide greater economy and better packaging results. The Milprint man showed us a typical example of a lamination to meet specific needs. It was one developed for packaging dry yeast, another product with an even greater moisture problem than ours. First, to keep the rough little grains of dry yeast from wearing through the package, a layer of pliafilm was used for the inside. This also acted as a moisture and air barrier. Next to this was bonded a thin layer of foil, which increased tensile strength as well as giving the desired dead folding characteristics. It also increased the package's effectiveness as a moisture and air barrier. They certainly knew our problem by heart, J.B. Next to this was then bonded a paper which strengthened the thin outer foil which was wanted on the outside. Because through the years, the public had come to associate the product with the foil appearance. And there it was, the right combination for a particular packaging application. So you see, J.B., they knew all about our problem. They'd met and solved even harder ones than ours. And I felt pretty confident that they'd find the answer, an efficient package with real sales appeal. At the end of the meeting, we were invited to take a tour of the plant. And I can assure you, J.B., that Milprint's production facilities are mighty impressive. I understand it's largely because of their investment of many millions of dollars in plants and their special facilities on both East and West coasts and in their main plant in Milwaukee that these laminated materials can be produced at a cost and in a volume to meet anybody's needs. And that's something just everybody in the business can't do. Then, of course, they have the special know-how. For example, some of their machines are specially designed for wet laminating. Here, heat and pressure drive out the water, of the wet adhesive right through a material such as paper as the materials are bonded. This gives a fast, economical run for some materials where low cost is important. And since you can't drive water out through non-porous materials, such as foil, vinyl, or cellophane, when they bond two such materials, they're likely to use another basic process known as thermoplastic lamination. The special adhesive used here is applied in a solvent solution. Quickly dried, this adhesive bonds these materials like they were welded together. One of the processes I thought was extra tricky was polyextrusion laminating. Now here the adhesive or bonding agent is molten polyethylene, squeezed out of a narrow slit. When this material's flowing just right, they move it in with a device something like a gun carriage and let it flow between the materials to be joined. After these materials are passed over chilled rollers, they're not only strongly bonded, there's an additional layer of plastic in the lamination for extra strength and additional barrier characteristics. Then, of course, there are the many wax coating and bonding processes where they use up thousands of pounds of different waxes every day. These melted waxes are piped around to the appropriate laminating or coating machines to produce materials with characteristics such as the ability to take and hold a dead fold, heat sealing during packaging, or even an inexpensive moisture or vapor protection for certain products. The right combination for the particular packaging problem is the key to this company's success, JB, and the individual characteristics of the bonded materials is of the highest importance to this right combination. So at every stage of production, samples are taken. Continuous tests are conducted in their quality control labs for absolute assurance that the characteristics selected and designed into the lamination are maintained. And you should see what a series of tests these samples get. They test for moisture content of the basic materials. They test for the exact amount of adhesive applied during lamination, for a material's resistance to moisture or vapor, a material's resistance to scuffing, for the tensile strength of the bonding agent, for resistance to tearing or ripping, resistance to breaking from impact, and they test for the material's bending characteristics. As you look around at all the different activities going on at Milprint, you begin to appreciate what it takes in the way of men and machines to turn out packaging materials in which you can have confidence. And you can tell that all these people know their jobs and know them well. The men in basic research, creating new methods and materials for constant improvement in packaging. The men in the machine shops, designing new equipment of the highest quality and efficiency to meet the increasing demands of the packaging industry. The designers and engineers, combining art with science to meet any customer-specific packaging requirements. The pressmen and the laminating crews, all trained and experienced in volume production with the highest uniform quality. The tremendous amounts of equipment and facilities of a company ready to service a worldwide packaging market. It takes the right combination of materials to solve a packaging problem. And it takes the right combination of men and machines to solve that problem efficiently and effectively. Milprint is that right combination, and Milprint gave us the right solution. And so, JB, that's how our problem was solved. The results of that solution can be seen in our increased sales. Once that moisture problem was licked, we had confidence in our product. Our sales and advertising staff started to really develop business. Milprint gave us the right combination, all right. For our product, JB, it's been the winning combination.